Hey guys, welcome back to Business Statistics. This is going to be the walkthrough for the Module 8 problems of the Module 8 and 9 review. So it's going to be review problems 1, 2, 3, 4, 5, and 6. Everything after that's for Module 9, but this should help you get prepped for the test. Alright, let's get started. Review problem 1. A production line operates with a mean filling weight of 16 ounces per container. Overfilling or underfilling presents a problem, and when detected, requires the operator to shut down the production line to readjust the filling mechanism. From past data, a standard deviation of 0.8 ounces is assumed. A quality control inspector selects a sample of 30 items every hour, and at that time makes the decision of whether to shut down the line for readjustment. Level of significance is alpha equal to 0.05. And then it splits the problem into two, so we're actually going to be running two hypothesis tests here. 10 a.m. sample indicated a mean of 16.32 ounces. Conduct the appropriate hypothesis test. What should the operator do? And then B, the 3 p.m. sample indicated a mean of 15.82 ounces. Conduct the appropriate hypothesis test. What should the operator do? Okay. So let's just kind of solve this as if we're just solving for solving problem A right now. Okay, let me get this pen working. Should be good. So we're just going to solve as if we're solving for A right now, and we'll just pretend like part B doesn't even exist. Okay. All right. So the first thing that we need to do, the first thing that I generally like to do, is kind of go through the problem and pick out things that we sort of think or know. And I kind of accentuated them when I was reading through it. But one thing that I noticed, a production line operates with a mean filling weight of 16 ounces. Sounds like a mu. Sounds like it's a broad assumption. It doesn't sound like a calculation. It sounds like it's something that's assumed. So it's kind of like a mu, or we can assume that that's a mu. Overfilling or underfilling presents a problem. So that to me kind of suggests that we're talking about an equals, non-equals kind of scenario. Overfilling or underfilling. If it was one or the other, if it was like greater than or less than type, overfilling would be the issue, or underfilling would be the issue. But because we're not picking a side here, we can kind of assume that it's going to be equal, not equal, because either side is bad, right? We want this machine to operate within the specific tolerance of 16 ounces. Over or under is going to be bad, and it's going to produce as a bad product, okay? Okay, readjust, blah, blah, blah. From past data, a standard deviation of 0.8 ounces is assumed. From past data, okay, is assumed. That suggests that this standard deviation of 0.8 is a sigma, not an S. The assumed word is an important word. The past data is an important word. These kind of speak of you talking about a parameter, some aspect of the population, not some aspect of a sample. Okay. Quality control selects a sample of 30 items, so that's our sample size n. And makes the decision whether to shut the line down, and a level of significance is given to us there. So great. Okay, so let's go ahead and get started. So in 1, my pen better not be doing this today. Okay. In 1 we have H naught, HA, and I'm going to have to shut the video down and turn it back on if it's going to do this. We have H naught and HA, and what parameter are we working with? We're working with mu. So we know mu, and then there's going to be some operator here, and what is our mu? 16. Okay, so we're working with the parameter mu, and we've got 16. So now the question is this greater than or less than? Well, we just talked about that. This is going to be an equals, not equal scenario. And the status quo is always going to be kind of what the assumption is. The assumption is that we're 16. Okay, And so then the alternative is going to be the thing that we suspect is the case, or the thing that we're testing for. We're testing to see if it's not equal to 16. So that's always going to be in our alternative. Okay, and then the status quo is always going to be in our H0. Okay, and so then 2 is, hey, what's our significance level? And we know that's 0.05. Okay. And 3 is, what statistic are we using? Okay. And the big thing is, we determine this by, hey, what are we using for a, like what parameter are we checking? Well, we're checking mu, right? So then that tells us we can either use the z-test about a population mean or the t-test about a population mean. I'm actually not going to pull up the grid, but basically you can look at the grid if you would like, and it's either going to be the z-test about the population mean or the t-test about the population mean. And what differentiates those two is, for the z-test about a population mean, we would have to have a sigma in the problem, and for a t-test about the population mean, we would only have to have an s. Well, in this problem we happen to have sigma, right? 0.8 is sigma. So we know then that we're going to be using the z-test about population mean. Okay? And that formula is equal to z. What on earth is this pen doing? There. All right. Okay, and that is our formula. So then step 4 is where kind of the magic happens here. This is when we start to we draw our curve, and we want to draw our curve. We want to figure out what our critical values are, and we want to make our rejection rules, right? So then the first question is, well, what kind of curve is this? Well, we know that this is a z-curve because we can look at steps 1, 2, and 3. We see, hey, we're using a z statistic. But honestly, this is all just going to be a messy drawing of a bell curve, right? So the z and the t look similar, so that's not important. But it is important to know what test statistic we're going to be using, because that is going to inform us of what type of critical value we're going to be looking for. So this is going to be a z, right? It's going to be a z curve here. Okay, and then the first thing is we look in step 1 to say, hey, is this one-tailed or two-tailed? Okay, well, we can see that this is an equals, not equals scenario, so it's two-tailed. That's what tells us it's two-tailed. So we kind of just write in some tails here. And then the next thing is, how big are these tails? Well, for this, we look at alpha. We have alpha of 0.05, which means that our tail size, because we have two tails, is going to be half of alpha. 0.025 and 0.025. Okay, and so then we know that this is going to be the z value of 0.025, and this is going to be the negative one, for goodness sakes, and this is going to be the positive one of 0.025, and I know from experience that this is 1.96. 1.96. Okay, and so then we make our rejection rule. We say, so basically this is our RR, this is our RR, and then we say, so this would be known as z-crit negative, and then z-crit positive. If z-calc is less than Z crit positive, or sorry, Z crit negative equal to negative 1.96. Reject if zcalc is greater than zcrit positive, which happens to be equal to 1.96. Reject as well. Okay, so that's our rejection rule. And then in 5, we calculate our test statistic. Okay, sorry for the abrupt change in the ink color. Had to change versions of Word in order to see if I could get the pen to work better. So, okay. And so then we go ahead and we do this zcalc value. So we do our formula here. That's just going to be 16.32 minus 16 all over 0.8 divided by the square root of 30. And that's going to leave us 2.19. And then we could see that 2.19 so we would say reject because zcalc is greater than zcrit positive, which is 2.19 is greater than 1.96. And then I'm actually not going to write this out just because it would take me forever, but I'll read it. So because we reject, right, so the production line was not filled at the 16 level and should be shut down. Okay. Now you guys, I'm supplying you with these notes. So if you don't want to hear my monotone voice kind of walk through these problems, that's fine. You can always just look at the solutions manual, but I wanted to kind of put this video out there to explain my thought process while we do it. So the actual written step 7 is going to be in the scan, and that's already out there for you. So if you want to see that. But if you're looking to learn and really looking to study, I think what you should be doing if you're going to watch these videos is to come at it with the blank sheet, you know, and walk along with the problems alongside me as I do them, or try them and then do them, you know, try them, see if you get them right, and then watch the video. All right, and now we're going to do part B. So part B, steps 1 through 4 are the same. Okay. So, because nothing changes about that, right? Nothing changes about our hypothesis, nothing changes about our alpha level, nothing changes about the fact that we were given a sigma, and then thus we use the z-test about the population mean. And nothing changes about how we reject, right? Because nothing in steps 1 through 3 change, so nothing in step 4 should change either. But what changes is the fact that we have a different sample, right? So once we have a different sample, step 5 is different, because then that's going to mean we calculate a different z-calculated value. So we can go ahead and start at step 5. So step 5 is 15.82 minus 16 divided by 8 divided by the square root of 30. And that is going to equal negative 1.23, which negative 1.23 happens to kind of be in the middle of this. So it's kind of in the fail to reject region. Not kind of, it is in the middle of the fail to reject region. So 6, we fail to reject because effectively zcalc is between zcrit positive and zcrit negative. And that's to say that negative 1.96 is less than negative 1.23 is less than 1.96. Okay, so then 7 is there's not significant evidence to suggest that overfilling or underfilling going on, and then thus there's no need to shut the line down for production. Okay. All right, on to number 2. Let's get through these. It is late, and I would like to get through these. All right, review problem number 2. The annual salary for the first year for first-year public school teachers in the state of New York is 45,250 with a standard deviation of 6,300. A sample of 95 first-year New York City teachers showed a mean salary of 47,000. Based on the sample, can you conclude that the New York City teachers have a higher mean salary than those in the state of New York? Let alpha be 0.01. Conduct the appropriate hypothesis test. Okay, so the first thing that I do is I go through and I try to pick out the things that we know. The average salary for the average, right? That's kind of indicative of mean. Okay, so state of New York is 45,000, and then we have a sample of people of New York City, okay, with a mean there, so that's a sample mean of 47,000. And then it looks like it is asking us to determine if the New York City teachers have a higher mean salary than those in New York. So we're treating New York, the state, as the status quo. And thus we can conclude that this 45,250 is the mu. Okay, we know that the 47 is then the x bar. Okay, and then we have a sample. And we kind of knew that the 47 was an x bar just because it mentioned that it's a sample. And it's going to be 95. And the standard deviation pertained to New York State, so that's going to be part of the population, so that's going to be sigma. And then alpha is given to us. Okay, and then the only other thing that we can kind of get from here is that it says, based on the sample, can you conclude that the New York City teachers have a higher than those in New York? All right, so higher. So that's going to suggest that our HA is going to be greater than. Okay, because that's what we're trying to check for, right? That's what our suspicion is, not what our status quo is. Our status quo is that they would be like the same, right? And so this is why we're always going to write our HA first, because then our status quo formally is going to be the opposite of that. All right, so number one, H naught, HA. Yeah, this pen writes so much better. H naught and HA. Okay, and so then we're going to check. We're obviously working with mu now. And then 45,250, 45,250. And then our HA is going to be greater than, and then thus our H naught is going to be less than or equal to. So 2 is, hey, what's our alpha? What's our significance level? 0.01, it's given to us. Fantastic. Number 3 is, okay, what kind of a test are we doing? So because we're testing the mean here, we're either going to be the z-test about the population mean or the t-test about the population mean. And because we have a sigma that is given to us in the problem, we are going to be the z-test about a population mean. Okay, and so that's going to actually be the same formula that we used last problem. Sigma over square root of n, so that's fantastic. Number 4 is where we draw our graph. Okay, and so we know that it's a z-curve, and how many tails is it? Well, we look up into our hypothesis. And our hypothesis shows us that it's a directional, right? It's not equals, not equals. So it's going to be pointing to one side, so it's going to be a one-tailed test. And what side is the tail on? You always look at the HA. So the HA, it's pointing to the right, so it's on the right tail. Okay? So this is our rejection region. How big is the rejection region? We always look at our alpha value. So our rejection region is going to be 0.01. Cool. So this is a z value. So we're going to be finding the z. So this is going to be called z crit. And this is going to be the z value where 0.01 of the probability is above it. Okay? And I know from experience that this is going to be a positive 2.33. If you would like to look that up, you can find in your table, okay, the z value where 0.01 of the probability is above it. You can also then, or conversely, that's going to be the same as looking for where 0.99 is below it. All right. Okay. So now we're going to establish our rule. So we're going to say reject if z calc is greater than z crit, which is equal to 2.33. Okay, so we run our calculation, and we get 47, so we say zcalc, 47,000 minus our 45,250 all over our sigma divided by the square root of our n. And when that all shakes out, it's going to be 2.71. All right, and then so for step 6, we're taking that number and we're comparing it to our rejection rule. Our rejection rule was saying, hey, reject if it's greater than 2.33. Well, 2.71 is greater than 2.33. So we reject because zcrit is greater than, zcalc is greater than zcrit. And that's saying 2.71 is greater than 2.33. And thus we have significant evidence to suggest that New York City teachers do have higher salaries than that of the teachers of all of New York State. There you go. There you go. All right, review problem 3. The Motor Trend New Buyer's Guide listed the Ford Taurus as having an average highway fuel efficiency of 30 mpg. A consumer interest group believes that the actual mpg is less, and that Ford may be overstating the miles per gallon rating for this model. A sample of 50 mileage tests with the Ford Taurus showed a mean of 29.6 miles per gallon and a standard deviation of 1.8 miles per gallon. Conduct the appropriate hypothesis tests at alpha of 0.01. What conclusions can be drawn from the sample results? Okay, so this one is kind of tricky. All right, you just really have to pay attention and not be fooled by kind of the words that they use. All right, so let's just go ahead and do what we normally do here. The efficiency, it's listed as having efficiency of 30 mpg. Okay, that sounds like, miles per gallon. That's an average, so that's going to be our mu. All right, and we know that it's our mu and not like an x bar because it says it's listed as. It's like this assumption. It's kind of a broad assumption that this is the case, right? This would represent kind of our status quo. Hey, it is thought to have, that sort of thing. Okay. A consumer interest group, however, believes that the actual MPG is less and that Ford may be overstating the miles per gallon rating for this model. Okay, so that's important, right? So if you notice something, they say the word overstating and they say the words, actually believe it's less, right? So those mean the same thing, but overstating kind of makes you feel like you're going to be using a greater than sign, but that's not the case, right? The suspicion is that the MPG is less, right? And they're not lying. They're not trying to confuse you. It's just you have to be very careful with the wording of the problem, right? I could see how that could be confusing. In fact, I think the first time I solved this, when I was first teaching this class, I think I probably set up the thing the wrong way and then realized, like, after the fact, solving it, oh yeah, it's right, because they worded it kind of funky. But anyways, so this suggests a less than in our HA. Okay, sample of 50 mileage tests, so that's our N, has showed a mean of 29.6, so that's going to be our X bar, our sample mean, and a standard deviation of 1.8. So that standard deviation is from the sample, so it's an S. Simple as that. And conduct the appropriate hypothesis at alpha of 0.01. All right, so let's sort it out. So H naught, HA. This is going to be about a mean. And we just established that we think that they are overstating, and then thus we have a suspicion that the MPG is actually less than they're saying, right? So less than 30, greater than or equal to 30. So then 2, our alpha level is what is given to us in the problem of 0.01. 3, what statistic are we using? Now this is the change here, okay? The change is that we don't have a sigma, we only have an S, and we're working with a mean. So t-test about population mean. And this formula is super similar. X minus mu, same thing, over S minus square root of n, not sigma. Okay, and then 4. Let's draw our picture in our rejection region. Okay, so this is going to be a t-curve. So that's just going to inform us that our critical value is going to be a t-statistic. And then what direction is our rejection region in? The left, because we just look at our HA, whatever way it's pointing, the left. So this is our rejection region. How big is the rejection region? That's the size of alpha, because there's only one rejection region, that is. And so then this is, and then, oh yeah, and then our n is 50. And so now we need to be thinking in terms of what is our DF, our degrees of freedom. That's just going to be 50 minus 1, so 49. That's just something that's special when working with T. So our T crit is then going to be T of 0.01, comma, our degrees of freedom 49. Okay, so then you would look that up in your table, and I'll go ahead and show you how to do that, even though I know we've done this before. So we go over to this table, we look for T of 0.01, because that's our alpha level, and then we scroll down to our degrees of freedom number, which is on the next page. T of 0.01, degrees of freedom 49, we get a 2.405. Yes, 2.405, and then is this going to be positive or negative? It is going to be negative because it is on the left-hand side. So it is going to be negative 2.405. Okay, so then reject if T calc is less than T crit, which is equal to negative 2.405. Okay, and then 5, let's calculate our value. So we go ahead and do that, and we get T calc is equal to 29.6 minus 30 all over 1.8 divided by 50. And then we get a negative 1.57. And that is not less than our critical value. So we say, so 6 is fail to reject because T calc is not less than T crit. And that's to say that negative 1.57 is not less than negative 2.405. You can do is greater than. This is just my custom. That's how I do it. All right, and then I would say we do not have significant evidence to suggest that the MPG is being overstated. Simple as that. Okay, number 4, we are trudging along. This is going to be a long video. I apologize for that, but for your studying needs, I'm sure you'll be happy to deal with it if it'll help you get an A. All right, problem 4, the Chamber of Commerce of a Florida Gulf Coast resort community advertises the area residential property is available at an average cost of $125,000 or less per lot. Suppose a sample of 32 properties provided a mean of $130,000 per lot and a standard deviation of 12.5. At the 0.5 level of significance, can you conclude that the resort community is understating the cost? All right, so let's do what we do here. And advertises that the residential property is available at an average cost. So this is our status quo, 125 status quo. It advertises this. They're suggesting that this is the case. This is the known quantity. That's sort of the thing, right? Then there's a sample of 32 properties. Sample size is n. That sample mean, it's stated that it's a sample mean, is 130 with a standard deviation of 12.5. So that has to be an S. Significance level of 0.05. And can you conclude that the resort community is understating the cost? So what does that mean? That means that we actually think that the cost is greater than what they're saying, right? So that speaks to our HA. So we actually think that it's greater than. Right, so this is why you have to think about what's in the problem, because understating makes you want to put a less than symbol. But really it's saying our suspicion is that the mu is greater than what the status quo is. Okay? Alright, so 1, H naught, HA, mu, 125, greater than, less than or equal to, just like that. To our alpha is given to us at 0.05. 3. This is going to be a t-test again, because we have an S, right? So t-test about a population mean. And that's t is equal to x bar minus mu over s divided by square root of n. And then 4 is our picture. Okay, and so then we look here, is it one-tailed or two? It's one-tailed. We can see that in our H in our hypothesis. What side is it on? It's on the right side. We looked for HA for that. We just want to see where the directional is. How big is that tail? Well, the tail is 0.05. Okay, and so then basically we want to establish this t-crit value. So this t-crit value is going to be a t-value of 0.05, and what is our df? So we have a sample size 32, so our df is 31. So this t-critical value, I guess we'll look this up in the table again. All right, and now where are we? Okay, 0.05 we're looking for, and then the critical value of 31, so we get 1.696. 1.696. All right, and so then we would just say we reject if t-calc is greater than t-crit equal to 1.696. There you go. That's a 696. All right. 5, and then we calculate t-calc is equal to the sample mean 130K minus 125,000 and divided by our sample standard deviation of 12,500 divided by the square root of 32. We calculate that out and we get 2.26, and then we say reject. Reject because t-calc is greater than t-crit, which is 2.26 is greater than 1.696. And then our step 7 would be, we can conclude because of significant evidence that the Chamber of Commerce is understating the prices. Okay, problem 5. Review problem 5. Review problem 5. Shell Oil office workers were asked which work schedule appealed most, working 5 8-hour days a week, the current schedule, or working 4 8-hour days a week. Shell management is trying to obtain statistical support that shows that significantly more than 50% of office workers prefer the 4 10-hour work week before making any changes. A sample of 105 office workers showed 67 preferred the 4 10-hour schedule. Conduct the appropriate hypothesis at alpha of 0.01. Okay, so we've got sort of a status quo proportion here. Okay, the general assumption is that about half have this feeling, and we want to check if more than half have it. Significantly more, so that's going to be greater than, and then we have a sample size of n, we have an alpha 0.01, and we have a number of occurrences x within the sample size. So before we even get started here, oh, this 50% would be a p as well. So before we even get started, we note that our p hat x over n, right? And then 67 over 105, or 0.6, what is it, 0.6381. And I think on tests, it's probably best to at least go with 3 digits when you're calculating stuff like this. I happen to go with 4 here, but I think 3 would have been fine, and I'm not gonna mark anything off for that. Okay, so that's just all junk before we get started. So number 1, it's our H naught and our HA. All right, so we're working with proportion, so P. Okay, something, something, and our assumed proportion is 50%. Okay, and then what do we suspect? What are we checking for? We want to check if it's greater than 50%. And then thus our status quo is the opposite of that. Our alpha level is given to us in the problem of 0.01, so that is number 2. And then 3, because we only have one test when working with proportions, we just know that it's the z-test about a population proportion. And that is z is equal to p hat minus p divided by p times 1 minus p over n. Okay, and then 4. What kind of curve are we working with? We're working with a z-curve. All right, and how many tails does our rejection region have? It has 1 tail because it's a greater than less than. What side is that tail on? It's on the right side because we look at our HA. How big is the tail? We look at step 2. Our alpha level is 0.01, so our rejection region is over here. So our z is going to be a z of where there is 0.01 of the probability to the right of it. So that is going to be 2.33. Then thus we reject if z calc is greater than z crit. Should have put crit right there, which is equal to 2.33. Okay, scroll, scroll, scroll. There we go. And then number 5 is us calculating this. So this would be z calc is equal to our p hat 0.6381 minus our assumed mu 0.50 divided by our assumed, I said our assumed mu, I meant our assumed p, 0.5 times 1 minus 0.5, which just ends up being 0.5, divided by 105. This is going to shake out to 2.83, and then we can say reject, because z calc is greater than z crit, because 2.83 is greater than 2.33. So it's going to end up over here somewhere. All right, and then this is going to say we have significant statistical evidence to suggest that greater than 50% of workers prefer the 4 10-hour work week. Cool, cool. Oh my goodness, what is going on down here? Oh my goodness. All right, I don't even know what I'm supposed to do with this junk. Let me pause and erase it, and you guys will just snap your fingers and it'll be gone. All right, and I'm back. See, finger snapped and all the junk is gone. All right. A study by the Center of Disease Control, CDC, reported that of people who smoked at some point in their lives, 50% have been able to kick the habit. Part of the study suggested that the success rate for quitting differed based on education level. Assume that a sample of 100 college graduates who smoked at some point in their lives showed that 64 had been able to successfully stop smoking. Test to determine whether the college graduate success rate differs from the overall population of smokers. Let alpha equal 0.01. All right, so we're clearly dealing with a proportion here because it gives us a percentage. It's not a mean. So we've got a p here. And we're kind of making this overarching statement. So we know this is our p, not our p hat. Part of the study suggests that the success rate for quitting differed based on education level. Differed is an interesting word, right? So that kind of suggests equal, not equal, right? Assume that a sample of 100 college graduates, all right, sample of 100, so that's n, who smoked at some point in their lives showed that 64 had been able to successfully stop. X. Test to determine whether the college graduate success rate differs. Yeah, so it says it again. So differs from the overall population of smokers. So this is going to be clearly an equals, not equals scenario, because this not equals is like kind of written all over this problem. And they give us alpha again as well. So step 1 is our H naught and our HA. Okay, and we know we're going to be working with a P here. Oh, and let's just go ahead and calculate our P hat right off the bat too. So P hat is X over N. And then we just have 64 over 100, and I can do that one in my head. So that is P hat equal to 0.64. All right, so P hat, or so P here. So H naught is P with an operator and 0.5. What is that operator? I think we just decided that it's going to be equals, not equals. Our not equals is always in our HA. Always, always, always. Our equals would then be in our H naught. Number 2, what's our alpha level? Given to us in the problem of 0.01. 3, what is our statistic? Well, we only have one statistic that we've learned to deal with population proportion. So it's going to be that one. Z-test about a population proportion. The formula is Z is equal to P hat minus P over P times, or over the square root of P times 1 minus P over N. Okay, and then 4 is draw a picture and find our critical value. Okay, so then this is, what kind of picture is this? This is going to be a Z-curve, because this is the type of distribution we're working with. How many tails is it going to have? It's going to have 2 tails, because this is an equals, not equals scenario. How big are those tails going to be? Well, because it's 2 tails, we have to split our alpha. So they're going to be 0.005. Okay. So we're going to have Z of 0.005 on the top, Z of 0.005 on the bottom for our Z crit negative and our Z crit positive, and then these numbers are going to be, if you remember, the 4 that I told you to memorize, negative 2.58, positive 2.58. You can look and find those on the table if you would like. But for a tail of 0.005, that's going to be a 2.58 Z value. So then our rejection rule is, because these are our rejection regions as always, reject if Z calc is less than Z crit negative, which is negative 2.58, or reject if Z calc is greater than Z crit positive of positive 2.58. Okay, and then this leaves us just with really one less piece of work to do, and that's, calculate what our Z calc is to see where it's at. So we calculate our Z calc and we get 0.64 minus 0.50 divided by 0.50 times 1 minus 0.50, which is just 0.50, divided by 100. We go ahead and we calculate that out, and we get 2.8. Gosh, we got really similar Z-calcs in both of these problems. We get 2.8. And then in 6, excuse me, we would say we reject because Z-calc is greater than Z-crit positive. 2.8 is greater than 2.58. All right, and then in step 7, we would say significant evidence exists, or we have significant evidence to suggest that the college graduate success rate differs from 50%. All right, guys. Well, I'm sorry for the 45-minute video, but I hope that this helps you. Please let me know if you have questions on any of this. I'm here to help, and I would love to answer any questions that you have and set you up for success for this exam, okay? There's just a few multiple choice questions on it. I think it's going to be 5 multiple choice questions. And There are 5 scenario-based, 2 of which are going to be confidence interval problems, and 3 of which are going to be hypothesis testing problems. If you followed along with the videos, you can kind of guess what's going to be on there. You can kind of guess what it's going to look like, because I'm really not going to test you on stuff that we've not covered. And then there's going to be 1 small extra credit question. Okay, but I'm not going to tell you what that is, but it is something that we covered in 6, 7, or 8. Maybe it was even in 7. I don't know. All right, I'm being too coy. And if I want to use these videos for future semesters, I have to make them more vanilla than this. All right. Thanks so much, guys. Please let me know if you have questions. I'll be happy to answer them over the weekend or prior to the exam. All right. Thanks so much. Have a good one. Bye.